All right. So I hit the wrong button.
Maybe mute yourselves. Oh. Okay. Yeah, so let's start the introductions. I think I had the order reversed, but doesn't matter. So yeah, welcome to the Awesome Python meetup. No. Yeah, I think I had I think I had Sam first, but
No, that's totally fine. Go ahead, Sam.
You go for it, Tyler. We did the other way around earlier.
All right. I'll let you finish the intro or let me know.
Yeah. So let's go start with that. Yeah, so welcome to Awesome Python meetup, the second meetup of the year 2021. Thank you everyone for coming, and everyone from Austin and then from around the world. This is since the lockdown, this has become more of a global event, I should say. Today we have two presentations. The first presentation is authorization patterns for GraphQL using OSO with the Python graphene library. And the other is QHub, deploy Jupyter Hub with Dask Gateway on Kubernetes in 15 minutes. And our presenters today are Sam Scott, who is the co-founder and the CTO of OSO. So hopefully I've said it right, not OSO, but OSO, which Sam just told me that means bear in Spanish. So, and he received his PhD in cryptography, and he's an engineer by training. And he can discuss everything from authorization and security patterns in Python and Django to how OSO works under the hood and interfaces with Python via FFI. So probably you have to tell us what FFI is, because I don't know. And he can also talk about trends in security policy as code and contributions to the TLS 1.3. Our next presenter is Tyler Potts. He's a coder at Quansight. And he's a data scientist and core maintainer for QHub Cloud and QHub OnPrem. And he's an open source advocate. He recently arrived to the DevOps party, and you can check his projects at GitHub. So we posted his links on our meetup page. So please check those links out. Tyler graduated from the BYMU in Neuroscience, and he likes chicken. That is to raise them and eat them. I definitely like chicken too. So, but only the second part, eating them. Yeah. All right. So I should take a decision. All right. So let's go with Sam. Sam, tell us more about authorization patterns in GraphQL using OSO and Python graphene library.
Sure. Tyler, you sure you don't want to go first?
I can go first if you want, Sam. You choose.
Yeah, why don't you go first? We'll mix things up to how it was before.
Sure, I'm ready. All right, let's do this. So I have a few slides prepared, mostly for the intro. I don't present often, so let me find this present button. Present. All right, so the title of this talk is Deploying JupyterHub with Dask Gateway on Kubernetes in 15 minutes. And so my goal in the course of this presentation is to accomplish that, actually deploy a completely open source data science platform on a cloud provider before I end this talk. And it's worked twice so far. So a little bit of table of contents of what we're going through, who I am, what is QHub. I'll go back into a little bit of the origin of QHub. We'll start the deployment right before I explain what QHub is, just to give us enough time for that to deploy. And then I'll showcase some of the features of QHub, and then we'll verify it's deployed and then move into QA. So who am I? I was not a computer science major. I'm a major and a co-founder of Anaconda. And you can read this if you'd like. This will be available in the Recording. QHub. What is QHub? So QHub is an automated cloud and on-prem deployment. So there's two versions of QHub right now. There's this cloud one, which we'll be describing today, and this has been in development for about, I'd say, 8 months officially, longer than that unofficially, as it kind of grew out of a need that we found for needing a data science platform when working with multiple projects with different clients. The on-prem solution came about because there was the need to actually get started with deployment. So here, I'll just show you, I can remove this. All this file has in it right now, and I don't want to get in it either. It's a little bit bigger. So all this file has right now is this nvarc file, and this is my way of handling Linux environment variables, where an environment variable is, if I did food equals bar, I could then echo that and get back bar. So this is our way of handling API keys. And so this file simply is a way of bash creating all of these files for me as I shift into a directory. But other than that, this is basically an empty file. So to start, we're going to run QHub init. I've done this a few times. I'm going to change this to demo 3 so I don't have any name collisions. And you can see there's a lot of different flags on this command line function. The reason for that is I'll go through it in more depth a little bit later. But that is what that initial command created. And you can modify this file before you deploy. The next step is to render this. So now if we look, we see that we have a whole bunch of files. And if we look at the tree, it created a lot of files in our infrastructure. These are various Terraform files and configuration files, and a few Docker files, a README, etc. With this, we're ready to deploy. So at this point, everything is configured to actually, like, if you looked at these files, you would have a definition of what cloud architecture is going to be spun up. So this is the last command, and when I hit enter, this will start deploying. Oh, hit enter twice. So it checks to say, hey, everything's all set up. Make sure you have your authentication in the file. And I do, so I'm going to hit enter to continue. So depending on how friendly Google is feeling on the day, this will take under 15 minutes and make me a truth teller, or take more than 15 minutes and make me a liar, as it did earlier today. End result, around 15 minutes, this will be deployed. Now, to actually show you what the platform is and does, let me pull this up here. This is just in Firefox. I happen to use like a container system with Firefox, so I can have 2 different instances at once. So let me go ahead and shut down the server. So this is JupyterHub at this point, running on Kubernetes. If any of you are familiar with JupyterHub, you should probably be familiar with this interface. So you can see here that this is a cluster I spun up previously. And in the configuration file, these were the 2 default ones, and I wanted an instance that had some more beef to it. And that's what this normal instance is. I've spun up instances up to like 150 CPU and 3.5 terabytes of RAM. Like, that's all up to you and how much you want to, hand off to Jeff Bezos or whoever gets money from Google at this point. Right now, for this one, I'll spin up a normal instance. This one will be fairly fast because I just barely killed the instance, so like the actual compute server is still running on Google, and you'll see that it's spun up. The reason I have 2 is because there's a shared directory between users. So each user gets allocated their own resources, and so some of you might have had shared servers where like you hop on the server and someone else is like running some big PyTorch job or like compiling something, and it hogs your resources. Whereas on here, each instance is isolated in its own Docker container. So if I go to show you here. This is like an interface into Kubernetes. And we can see, if I look closely, there should be a bot, which is this one. And you can see that this has been up for like 58 seconds. But what can we do with it? The great thing is it has Dask, and that's a big thing that got me into QHub. So there's auto scaling with Dask, and so here I ran this notebook. It takes a few minutes to spin up a cluster, and that's why I spun this up previously. But we can see here that we have Dask in a notebook, and up on the top right we have Conda environments. And the great thing about these environments is these are currently defined in a shared NFS volume. So they're built, and so everyone on the platform is using the same environment. And I'll show you where that's defined here. That's the building. At the bottom here. So it's very similar to a Conda YAML file where you would do like conda env create -f. You would have your Conda environment here. So you can select the environment for your notebook, and this is a notebook that a guy named Rich created. He does a lot of like national water analysis and that kind of thing. And you can see that you can spin up a Dask cluster, you can crunch some data, you can push that data into a panel app and eventually get a usable visual out of it, where this is a really pretty picture that hopefully will work. All just by logging in. And this is just kind of typical panel stuff. But let's say like you have this notebook and you want to share it with someone. So I have this notebook here, and this is this notebook in this national water model, and I want to copy this, and I put it into shared, I want to put it into users, and just paste this. So these two tabs are, you can consider like different users. You can see Tyler Potts up here, and you can see Quansight bot up here. So if we go into shared and we go into users, this notebook is here now, and I can copy this notebook and I can paste this into my home directory. And now let's say a fellow developer is having trouble with their code. They can just sling me their notebook that they're running, and I can see the notebook, see the code, and even the error messages that they were experiencing will pop up here. And that's something I used a ton when I was working on a project that was, our entire development environment was the predecessor to QHub. So, trying to think, shared Conda environments, shared NFS volume. Oh yes, GitOps, that's the next part. So let me pull this up here. So we don't want to, oh, that's not, here we go. So once this deploys, I will push this to a repo. And the purpose of pushing it to a repo is we have all of these, oh, we should have, this doesn't look right to me. I need to click a different one. There we go. We have these GitHub workflows. So if you remember how I ran QHub init, QHub render, that is done here as well. So whenever a push is done to master, it installs the latest QHub version. Excuse me, it installs the version you have pinned here, and it renders that configuration file, and then it will push those changes. And then there's some other GitHub workflows that will actually take those changes and run the Terraform commands necessary to deploy that. And so why is that cool? Because you can do things now like just create a PR updating QHub config.yaml, I think this one was updating the environment. No. Trying to find one add EMPs. There we go. So let's say someone wants to add a new environment or change an environment or update a version. What they can do now is they can check out a branch based off of main, and they can modify it and create a PR. And you can have someone else approve that, merge it in, and now you have like a versioning of where your environment was that everyone's developing on. Not only is it versioned, but it was versioned, and you can revert that version. So let's suppose someone like changes something in the environment which like breaks everything. You can revert a PR just like you can revert a PR in any other project, and it will go and redeploy the architecture to that previous version, because all it's doing is taking that Terraform files, like the definition of where the cloud resources should be, and making sure your deployment is in that state again. And similar thing, like if you need to add a user, like you no longer have to like personally add a user. You can say, hey, go to this file and follow the pattern to add yourself. And so that's like up here. You can say, oh, okay, let's take these people and add yourself in the file and deploy, and now you have another user authenticated. Yeah, so I think that's pretty much, I'm trying to think if that covers everything. I think this is still deploying. Yeah, that's pretty much QHub. We do have, like I said, QHub OnPrem. The main difference being it runs on Slurm. So instead of having like Kubernetes, which like auto scales your pods and will like actually get you more compute as you request it, it assumes that you have like a stationary amount of compute. The benefit being that it's generally faster and more stable, because like you assume that the connection is always going to be there, like your Ethernet is always going to be connected to the box. And the downside is you're kind of stuck in with a consistent cost. So as far as cost is concerned with QHub Cloud, like it runs about $80 to $160 minimum just for the Kubernetes engine plus the two small-ish compute instances to keep the software running. And then you can scale that out as big as you want. I've gotten clusters, I think, I've gotten about 700 nodes running simultaneously on a single QHub deployment. So it's super flexible. You can really do what you want.
Hey, Tyler. We've had a couple of requests that you could increase your font size a little bit. I think people are having a hard time seeing what's on your screen.
Okay,
thank you.
Not bad. But with that, I think like I'll keep an eye on this deployment. Like I said, it should take around 15 minutes to deploy. But are there any questions?
Many questions.
Go for it.
Okay, so I actually have a use case. I'm running a COVID model, and I need a lot of compute. I usually get it for all sorts of places that give me all sorts of compute time to use their platform. I'm currently interested in the ability to use new tools like this. However, I saw several things that I like and some other things I don't like. So one of the things I like is the ability to have a network file system deployed already with a shared network, a shared disk space for all of the nodes. So this is nice. However, I don't use Jupyter Notebook. I don't need it. I need like a console that I can run on some sort of Linux thing, saying run my program from that shared directory, and it will run. Can this help me?
Yes, let me see if I can. I don't remember the name of it. This one. So we're always adding features. So we used to have something called kubessh, where you could SSH into a pod. And so let's suppose your pod didn't exist already. It would authenticate you and then spin up a pod if your pod wasn't already existing, and then that way you could like have a tmux terminal or something and have your pod running on this cluster even though you weren't connected. Right now that got deprecated, and we're in the process of adding this JupyterHub SSH back, which would add some of that functionality. This JupyterHub SSH is password authenticated. It's not SSH key authenticated, which is like one of the hesitations we have. But this would, I think, be filling that use case you're asking about.
Yeah, it's a start. Another thing, I need Python too.
Okay.
Is the problem or not?
Well, I think you could just install Python 2 in your con environment, right?
Yeah. The question is whether you're like it will break something in your system if I use QHub.
Not really, because I think if you just have, I mean, this kind of goes back to you not wanting notebooks, but like the notebook runs on a kernel, and so if you're running Python inside of, let me think about it. If you're running Python inside of an environment that has Python 2, then you would be using Python 2, and it wouldn't affect QHub. Okay.
So this is nice. Now, the third thing, I want to upload my own data and stuff like this. Do I have to put it in a Docker image or something, or is it a way to upload the data like SFP or anything else?
So it depends how big your data is. If it's like a small CSV file, less than 100 MB, I'd suggest dragging and dropping it into here. So this interface supports just like dragging and dropping files. If it gets any bigger than that, I would suggest uploading it to block storage, be that S3 or Google storage, and then reading it into your whatever your process you're doing that way. Particularly if you're using, yeah.
So there's no way for me to actually create a directory structure that it's like uploaded when I start the system.
Well, I mean, like these files are persistent.
I need to actually run them on the NSF shared environment.
Yes. So this directory right here is all the NFS shared. So it's not optimized for any sort of large data because it's NFS. It's like super slow and it's lots of latency. Like you do have access to like your actual instance. Like what am I saying? The storage attached to your instance in like /temp here.
Here. You have console. Nice. This is what I need.
Yeah.
So you can have SFP, SCP or something stuff here, correct?
Yeah, I mean like this is a console connected to the internet, so like if you could do whatever you want.
Thank you. You answered my question. But someone else has questions because I was and you probably want to explain some of the things for some of the new beginners here because you were talking things high up with beginners here. So maybe tell them what a Slurm is or some of the basic stuff.
Yeah. Do you want me to answer any other specific questions that they're open?
So there's a couple here that have popped up in the chat. And so actually, speaking of Slurm, Ivan wants to know, so you could run that one with Slurm in your own institutional cluster or your own on-premise cloud. And is that a reasonable use case?
Yes, actually. So that's exactly what we're doing for your client. And right now,
explain what Slurm is for people who don't know.
Well, so I barely understand Slurm.
That's fair.
It's a resource allocation system, basically. It says what a certain user is allowed to have.
Yeah, so basically, like it was built, from my understanding, in the HPC heydays, where you want to specify exactly what resources each user can have access to and make sure that resources aren't allocated. So let's say you have a cluster of 100 computers and you have 5 users. You might want to have a user who hops on and says, hey, I need to use 50 of these 50 nodes, and so they'll schedule a job, and then the Slurm scheduler will go out to the cluster and find the 50 workers that are required to fulfill that job. And you can get even more granular by defining like how many CPUs and RAM are in a particular job, and you can even specify like how much CPU time each user is allocated. depending on how far down the rabbit hole you want to go. There's another question. So you could run that one with Slurm on your own institutional cluster or your own on-premises cloud. On-premise cloud, right. I think that's like a duplication of terms. So in my mind, cloud typically means like not on-premises, but you could do both. So to prove this, let me log into like a server that I'm doing some work on. So Quansight is partnered with a company called Bodo and Bodo is a way to try and compile Python code to work with HPC clusters. And so we have a webinar coming up next week, and so I'm doing a lot of QHub on-prem work to prepare for that. So right here, this is QHub on-prem, and if I cd into my tests and my GCP, and I look at my Terraform output, this is a cluster of like about 60 workers that I'm running. And the only requirement for QHub on-prem, the only requirement is that you have machines that are networked together that have either Ubuntu 18 or Ubuntu 20. That's the only requirement. So if you can have those access to that, and you have to be able to SSH to them with proper authentication. But beyond that, you can do whatever you want. So if you have these machines spun up in the cloud or you have them on-prem, it doesn't matter. It was kind of designed for on-prem because with HPC, like you can measure like the length of cable you have going from one box to another box and make sure that you like have the optimal performance. But if you wanted to, you could do this. Why do we require Ubuntu? That is kind of just the design decision that we went with at the time. I don't think it's a huge specific reason.
So there's a question a bit earlier up in the chat from Jenny that I want to make sure we don't lose sight of. They say, very nice presentation, ! Could you say a few more words on resource sharing between different users on the same server?
Great question. There is no resource sharing. Each person gets their own resources. So if I go here and I look at our bot here and I describe this pod, so these are Docker images, which are containers, and they are being managed by Kubernetes, which is a container orchestration system. And so Kubernetes is managing this container and specifically telling the container how much access to resources it has. So here you see that this particular container is allocated 15 CPU, and I don't know why Kubernetes does this. Kubernetes is kind of a mystery to me, and it allocates this much memory. So this user has access to 15.5 CPUs and 124 gigabytes of memory. If we exit out of that and we take a look at my user, you'll see that my user has a much lower amount of here. So I only have 1.5 CPU, and then this is 2 gigabytes of RAM. So as far as resource sharing is concerned, there is no sharing. Like if someone wants resources, the cloud will spin up a new server to provide the resources to them. Did I miss any questions? Could it be ported easily to Debian? I mean, Ubuntu is built on Debian, so I suppose if you wanted to. Like what QHub on-prem does is it uses Ansible scripts, and Ansible, all it does is SSH into a machine and run bash commands. So if you could configure a Debian machine to like have all the stuff you need to run QHub on-prem, you could totally do that if you wanted to. I'm not sure why you would want to, though.
This is maybe something that's worthwhile understanding, because there was a shift in paradigm in the last several years. Slurm is an older system that was developed to share resources between a bunch of users. Like multiple people in the university had access to a cluster and will use it some of the time. Now everything shifted to the cloud. These days, you actually say, okay, I need X computers, and I have them all of the time. So you no longer need really Slurm. It is used sometimes to allocate those computers, but Slurm is the old way of doing this. There were other systems like TalkDBS and SunGrid Engine and many others. Once the new system arrived, now people use Kubernetes to allocate things in the cloud, not only Kubernetes, but some other systems. And then once you have those computers, you just run Dask on them. It's much simpler, and those resources are dedicated to you. So, Jen, your question is a few years old. Today, we just don't share things. We just have them for a certain amount of time. The cloud systems allow us to share it.
So when you're running Dask, everyone's going to have their own Dask cluster, or would there be any sharing of a Dask cluster?
Each one gets their own Dask cluster, and you can configure that as well. So if I go here, I think I have a Dask cluster running. So we'll see here that there's a scheduler. So Dask has like a master worker methodology, and so the scheduler is the master, which actually has, again, resources assigned to it where that does all the task graph and whatnot. And then this Dask scheduler would have my workers attached to it. So I think I did it. Tyler, you can see here that I have one worker that actually spun up and then 3 that were pending, probably because I had the node group limit set too low or something.
Thanks.
Yep. I would say, like, kind of in reference to that Slurm versus Dask, I think there's different use cases for each, right? So Slurm kind of has this methodology using MPI where you don't have a master head node. You kind of have all of them in a cluster, and each node communicates with the other nodes to get the job done. And so in that way, once you scale, like, past, I'd say 100 to 1,000 nodes, and I don't have personal experience with this, there's some point where you get so big that it doesn't make sense for all of your data to go through the scheduler anymore. And I think it's probably, my guess is more like the research organizations and the like the very large, very rich corporations where it makes sense to go this route. But I guess that's an open question that remains to be seen.
So I can tell you Dask works very nicely on tens of nodes, and like I used like over 1,000 cores multiple times on multiple systems using Dask. So the old paradigm of Slurm is going away. Maybe Slurm is well designed for some things, but even with SunGrid Engine and all the systems that are centralized, you could spin up like 10,000 nodes. Like I know the people who did Star Cluster, they have a paper that they span 10,000 nodes. I don't know how well the computation went, but they were able to do this with, and the core there is SunGrid Engine, which is much older than Slurm. Interesting enough, I never tried it with Dask, but Dask is good enough for the needs you need today.
And maybe that finished deploying, and I can prove that it worked. Let's see here. Yes, it took, it made me a liar again today. This is like 16 minutes, which is a bit of a bummer. But if I do head and look at like the first 30 line, my QHub config, and take this here, we will see that we have a QHub spun up. Woo! Yay! Golf claps.
I mean, 16 minutes is pretty close to 15 minutes.
Yeah, I know, but like, it's just the fact that it's over, you know? Someone called me out. That was the last time too, and it was the first time it was over 15. But what can you do? I think that's it. I would like to do something if I could grab 1 more minute of time, Dylan. Is that all right? If everyone could take thank you. If everyone could take 60 seconds and like take what they learned from, or like what their takeaway from this presentation, don't hit enter yet, just type it out. And then at the end of the 60 seconds, hit enter. Please. Got about 15 seconds left. All right, hit enter in 3, 2, 1, go. Thank you, everyone. I guess I always talk faster than my allotted time. Are there any other questions or comments or concerns? I should mention, if you do want to contribute, like, we are very happy to have you contribute. So just go to GitHub, QHub, /cloud. This is the most active repository, and then we're also working on QHub OnPrem as well.
Tyler, someone asking if there a chance to work with Azure. You heard something about it in the beginnings. To answer that question.
Yes. Yep. So we are working. So I've had a conversation last week with a developer who's working on translating the Terraform scripts to work with Azure. So yeah.
And Jenny, the person who created Dask, or the main contributor, will be on the Python meetup soon, and Florin will tell you when.
Yeah.
His name is Matthew Hawklin.
I think it's next month, right?
I think it's next month, yeah. I was looking through, trying to find my notes with the presenters, but I think it must be probably next month. All right, any more questions? All right, well, thank you, Tyler. This was great. Thanks so much.
Welcome. Thank you.
All right, and yeah, if you want more information, again, check our Meetup webpage. I posted a couple of links to the QHub, so you can get more information there.